In this question number 4, so V is a colorless liquid. It's an organic compound containing alkenes. So we know that this is carbon-carbon double bond, alkene functional group. And then we have this C double bond or OH. We will call the family of compound to be carboxylic acid, but the functional group present is called carboxyl functional group because this is stated in the introductory organic chemistry specification. There is a table listing all the functional groups as well as the family of compounds you will call them. Now V reacts with an excess of LiAlH4. This is what you call reducing agent, lithium aluminium hydride. So as a reducing agent, it gives you a source of H-. This is called hydride ion. Now when you use this as a reducing agent, you cannot reduce alkene because alkene contains carbon-carbon double bond, which is rich in electrons. So cannot be reduced by lithium aluminium hydride because negative charge electrons and also negatively charged hydride, they don't like to come even close to each other. To reduce alkenes, you have to use hydrogen and platinum or nickel catalyst, but hydrogen and platinum or nickel catalyst cannot reduce carboxylic acid. So it's like give and take there. Okay, so now draw the structure of W. So W there will not reduce the alkenes, but it will reduce the carboxylic acid and become primary alcohol. So they said draw the structure. I started with 1, 2, 3, and 4. Carbon there, so there's 1, 2, 3, and 4. No change to the alkene, but the carboxylic acid now has become a primary alcohol. The structure, as I mentioned there, you could draw skeletal, which I did because the question gave me in skeletal. It's the easiest to work in skeletal. When I don't have a choice, then I will follow the question, but when I have a choice, I always do skeletal. I could do structural as well. If you are a structural person, then you will write this as CH2 double bond. I'm reading from right to left, CH2 double bond, CH, 1, 2, 3 covalent bonds, so there's one hydrogen there, so CH, and then CH2, so CH2 double bond, CH, CH2, CH2OH, so there's another CH2OH, that is also acceptable. If you want, you can draw the display formula where you show every single covalent bond, including the O and the H covalent bond. They didn't specify whichever one, so whichever one will be accepted as well. Identify the role of LiAlH4. We know that as a reducing agent, it reduces something else by getting itself oxidized. It goes from H- to become H2. So V reacts to form Z in a single reaction. So this going to that. What's going to happen there really is on the alkene chemistry. So the alkene chemistry, both the carbon gain oxygen. So I said both the carbon of carbon-carbon double bond gain oxygen. Gaining of oxygen atom is what you term as oxidation. In terms of electrons and oxidation number, those are more useful for metal and non-metal chemistry. For organic chemistry, a lot of the times we're looking at gaining or losing oxygen, gaining or losing hydrogen. Now suggest the reagent and condition. So this is definitely what you call the mild oxidation of alkene as stated in the syllabus. So the mild oxidation of alkene is done by using coal, dilute, and it must be acidified KMnO4. They didn't ask for the name of the reactant. I wouldn't go away and name the full thing together with the oxidation number. But if they do ask for the name in words, then it has to be acidified. Without acid, there can be no redox reaction with this oxidizing agent. And I must have the full name with the oxidation number VII. So that is representing KMnO4, where the whole compound has no charge, so 0 charge there. For the compound oxidation number, +1 for the potassium. Manganese is what you want to find, 4 times -2. For each of the oxygen is -2, and there are 4 of them. So each manganese there is going to be +7, and that's how we get the manganate VII there. Well, it's H+ to represent the acid required in the half equation, which you have done the redox titration as part of AS, as well as O-level and IGCSE chemistry. Now determine the empirical formula of Z. You got to work out the molecular formula first. In one molecule, how many carbon atom you have. So molecular formula defined as the actual number of atom in one single molecule. So we've got 1, 2, 3, and 4 carbon. In terms of hydrogen, we have got, let me see, what do we have there? Seems like this is a bit laggy there on the writing there. So C4 for hydrogen. And now the hydrogen, 4 carbon, 1, 2, 3, 4 carbon. In terms of hydrogen, we have got 0 hydrogen there. We got 2 hydrogen there because carbon form 4 covalent bond. There is 1, there is 2, so there is 2 more hydrogen there. Carbon form 4 covalent bond, 1, 2, 3 are shown, so there is 1 hydrogen there. So I can say 1 hydrogen, 2 hydrogen. There is 1 hydrogen on the OH. There is 2 hydrogen there because carbon form 4 covalent bond, and there is 1 more hydrogen on each of the OH. So I'm going to strike out the hydrogen now. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 hydrogen altogether. And in terms of the oxygen, there is 1, there is 2, there is 3 oxygen. So this is the molecular form. Hang on. 1, 2, 3, 4. There are 4 oxygen altogether. So I was about to say that cannot be simplified further, but this one definitely can be simplified further, divided by 4 throughout. So each of the atoms you can divide by 4 throughout, and what you're going to get now is going to be 1 carbon, because 4 divided by 4, 8 divided by 4 is going to be 2, and then you're left with 4 divided by 4, which is 1. So the simplest whole number ratio of the atoms is going to be what you call empirical formula there. In part 3, complete this table to show the number of sp2 and also sp3 hybridized carbon atom. So this is hybridization. We're looking at a molecule of V. So let me just copy paste this. So that is V. And I'm just going to move this to the other page where we can work with it. So in terms of this structure of V, we can tell that this is a trigonal planar. So we know sp2 there is your trigonal planar carbon, is your 120 degree carbon, whereas sp3 is going to be your tetrahedral carbon, which is going to be 109.5 degree carbon. So that is your trigonal planar. So that is your carbon sp2, where you got 1 bond pair, 2 bond pair, 3 bond pair, because this is a double covalent bond. So we said that, we only count the sigma covalent bond. So there is 3 sigma covalent bond. There is 1 sigma there, another sigma to CH, another sigma to CH, so 3 bond pair. 0 lone pair because carbon form 1 bond to the H, another bond to the H, 1 to the carbon, and the double bond there to the carbon as well. 3 plus 0. So when we get 3 plus 0, we will get 3 electron pair. So EP there refer to electron pair, which must consist of 1 of the carbon 2s. You use the 2s for mixing. Mixing with what? Mixing with the 2p of carbon. And the 2p of carbon is going to need how many of the 2p? 1 plus how many give you 3? 1 plus 2 give you 3. And therefore, we said that there must be carbon sp2. Similarly, on the other alkene carbon, we know there's carbon sp2 as well. And then this is a trigonal planar carbon sp2 carbonyl carbon there. We're just looking at carbon, of course. And there is 1, 2, 3, 4 carbon atom. So all the carbon atom accounting for sp2 and sp3, because there is no carbon triple bond there. And last but not least, we will have this carbon there with 4 bond pair and 0 lone pair. So there is 4 sigma covalent bond, where the carbon form 1 bond there, 2 bond there, another to the hydrogen, another to the hydrogen. So 4 covalent bond, 4 bond pair, 4 sigma bond there. And the carbon uses all 4 electrons for bonding, so therefore you are left with 0 lone pair. When the 4 bond pair repel equally without any lone pair, you're going to get tetrahedral geometry, which is 109.5 degree on this central carbon there. So there is only 1 carbon, which is carbon sp3, and there is 3 carbon. There is carbon sp2 there. So, there's 3 altogether. So that means 3 plus 1, so there is 4 carbon accounted for in the molecule of V there. Part C, Q contains these elements: carbon, hydrogen, oxygen, saturated. Saturated means no carbon-carbon double bond. Okay, well, in fact, it's not just no carbon-carbon double bond. There's no double bond at all. So it's just CC. So it's only CC single bond. That's what saturated mean. Now, no branching. No branching would mean it's a straight chain. So we're looking at something which is straight chain with no branching. And Q contains only one functional group. Bear in mind that in the syllabus, they specify that alkane is not a functional group. Alkane is not a functional group. This is as stated in the introductory organic chemistry syllabus in the Cambridge document. Now the relative molecular mass of Q is 88, so we can just add up all the relative atomic mass and get 88. No effervescence is seen when you add sodium carbonate, so that means that it's not carboxylic acid because it is not acidic. Now effervescence is seen when you add sodium, however, so it reacts with sodium but not sodium carbonate, so it means that it has hydroxyl group. The hydroxyl group there is just your OH group there, so it's not an alcohol functional group, it's just a hydroxyl functional group, which means that's the only one functional group present. It reacts with alkaline aqueous iodine. So we know that there is only one functional group. We know hydroxyl is present. We know alkaline aqueous iodine is a test for methyl ketone, which is CH3 C double bond O, or CH3 CHOH, which is your secondary alcohol group there. However, we know there is only one functional group. So that means that if you already have hydroxyl based on the test with sodium, and therefore it can no longer be the CH3CO, it has to be the CH3CHOH. So what do we know about Q? We don't know anything about Q, do we? Nope, there's no information on Q at all. So I just have to draw some stuff. I wonder if Q is related to any of these. There is no mention of Q at all in this question. Well, there was V, but V has got two functional groups. And what do we know about V? V has got 4 carbons. Let's see. What do I know? I know I must have CH3, CHOH. The thing is, the rest must just be alkyl group because alkane is not a functional group. If I just total up the number of molecular masses here, so that is 15, and I have 12 plus 1 for the hydrogen, plus 16 plus 1, so 12 plus 1, 13 plus 16 plus 1, I get 30. So if I got 15 and 30, so that is 45, and that means the leftover must be 88. 88 minus 45, which is the 15 plus 30. I get 43. So this 43, if you know your mass spec, you will know that these are normal alkyl group, which is going to be CH2, CH2. I think there's 14 plus 14 plus 15. Yep, I was right. So that is just your propyl group. And how do I know that there is no branching? Because there is no branching in the carbon backbone according to the syllabus there. Okay, so no branching in the carbon backbone there according to the syllabus. If I just make this a bit smaller, nope, that's too small. Just make that a bit bigger. So no branching in the carbon backbone, only one functional group there. So this is all following the question there. So if I can draw skeletal, or I can draw display, or I can draw structural because they say draw the structure. I'm more comfortable with my skeletal formula. So I'm just going to draw CH3CHOH, CH2, CH2, CH3. So CH3CHOH, my molecular formula, there is 5 carbon altogether. So C5H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I can get 1 O. So the MR of that, if you press a calculator, 12 times 5 plus 12 times 1 plus 16, I get 88. There is only one functional group, which is the hydroxyl. It's not acidic, but it does react with sodium. Alkane is not a functional group. It contains carbon, hydrogen, and also oxygen. It's saturated. There is no, it only has carbon-carbon single bond. And it does have this reaction with alkaline aqueous iodine based on the CH3CHOH, since it cannot have 2 functional groups according to the requirement in the question. There's only one answer there for that 2 marks and overall 8 marks question there.